time, of course, we see a fairly modern-looking globe. You see that most of the oceans that we see today are either opened or starting to open. And of course, a very critical thing, and maybe put that up for just a moment, is that the African region is rotating in a counterclockwise direction up against Europe. And this is going to produce a very significant series of events that starts in the Paleogene and continues in the Neogene. Here I speak of the Alps. The Alps are a region that lies south of the older Variscan orogeny, which was Carboniferous, more or less the part of our Allegheny. So we have an alpine fold belt all down through here. Just to point out, Italy is about here, Switzerland is in here, and this belt also continues to the east where it's called the Carpathians. So this is a major mountain belt. We see it all the way to England. This is Walworth Cove in Great Britain, taken a number of years ago, but this is a picture of these folded beds of Jurassic limestone, but folded during the Alpine orogeny. So Alpine orogeny basically been situated in time as later Paleogene and Neogene time. Okay, we click now. Whoops. Yep, the region again affected. Eventually it straddles all the way eastward through the Zagros Mountains, the Alps proper into here, and really almost continuous belts of deformation right into the Himalayas, which occur during the mostly Neogene period. What's happened to the Tethys Ocean, I asked? Well, that's what's happened. The Tethys Ocean closed by the rotation of Africa and the migration of India up against Asia. So the Alps, of course, spectacular mountains, extremely complex, more complicated than we could get possibly into. It would take a whole course really to discuss that, the dynamics of the history of this region. Again, Walworth Cove in England, really weird overturned S-folds in the Switzerland, the Swiss Alps, very classic region. The Jura are part of it, the name bearer for the Jurassic. I did give out this sheet. Is there anyone who didn't get last time's sheets? If so, raise your hand. Maybe Tom can give them out. These are important, these last two sheets. I'll try to have a distribution of these things out. I see from the number that are left here that probably some people didn't get them, so be sure you have those. Just a little bit of history on what went on in the Alps. Okay, so the African plate, this is an Italian diagram, but an African plate is rotating more or less counterclockwise here against Europe. Here's the Baltic or Eurasiatic plate through here. And in between, there's perhaps some smaller microplates, most notably the Adriatic. It's the Adriatic microplate, which is, I think, shown on the little diagram I gave you, which is being crushed in between Africa plate and Europe plate to push and close what had been a little ocean. If you go back to the Mesozoic, there was an opening, a rifting in the Triassic and Jurassic, what we call the Penninic Ocean. It's written on there somewhere, but P-N-I-N-N-I-C. And this then closed, starting in the later Mesozoic, but continuing especially into the early part of Cenozoic, where you have southward subduction of the European plate underneath the Adriatic plate. So here's this little tab being pushed over top of this, and as this happens, here's the Adriatic plate, kind of like a ramrod being pushed into the south part of Europe. And of course, this creates a series of overturned folds. The first one, the Penninic naps, which are actually an accretionary wedge being off straight. You can see that happens straight through here. And then this pushes, first, it fills a foreland basin with fish called the Helvetic Alps, and then the Helvetic Alps are then themselves pushed northward into the subalpine thrusts, and finally the so-called Molas Plateau. This is where both the words Fleisch and Molas come from, is in the Swiss Alps. And the Fleisch was mostly early Cenozoic, Paleogene, and it got crunched and pushed itself onto the Craton further north, creating even still further. Oh, the Juras lie in here too. So it's a really complex mess, a lot of overturned folds and extreme tectonics, I'll put it that way. Again, unraveling that has taken centuries, and it's still in the process. Okay, so by Middle Eocene, you have this together. Now let's talk a little bit about the Paleogene life that is going on at the same time. Of course, we think of this as the first part of the age of mammals, but there's a lot going on in other places too. The marine ecosystem, and you can click back up for a moment. Following the big extinction, there was a kind of recovery phase, and a number of things happened during this time. You rapidly re-expand up to unprecedented numbers of species and genera and families. Some of the things that appear during this time include the nummulites. Nummulites are huge forams that look diagrammatically like this. I mean, they are literally this big. And there's for single-celled organisms, I think they pretty much take the cake. They're about as big as it gets. You can see in cross sections they're full of these little chamberlets. The chamberlets were probably full of little symbiotic algae, which helped them to grow such big single cells. And I would note that some people in the past called the early Cenozoic or the Paleogene the nummulitic period because they're so much a part of the limestones along the Tethys Seaway. Not so much in North America, but in the Tethys region, especially areas which are today parts of Africa, Egypt. Limestones made of these in the Paleocene, Eocene time. And these include the limestones from which the famous Egyptian pyramids were built. They have these great big coin-like forms in them. And then, of course, mollusks. Mollusks are doing just fine in the coastal plain area. Here you can see a selection of some of these different things from this from the London clay, an original picture drawing by William Strata Smith himself, shark teeth, snails, clams. He was comparing them to the Cretaceous things that he had seen nearby. And here's some from the coastal plains. They look very modern. In fact, you'll remember that Charles Lyell used the percentage or proportion of ones still around today as a way of dividing out time in the Cenozoic. 5% was Eocene, 25% are roughly in there, Miocene, and so on. Another thing that evolves during this time are sand dollars. Part of the increased infaunalization, or things tending to go into the sediment, these sand dollars evolved and spread throughout the world during this time. Tremendous numbers of new fishes in marine and freshwater settings. The big breakthrough had come along in the Cretaceous time with the swim bladder, and the swim bladder permitted just an enormous radiation of what we call the teleost fish, the advanced fishes. And modern sharks, which also occurred in the Cretaceous or evolved in the Cretaceous, they're doing very well. They're, of course, the big reptiles, the mosasaurs, the plesiosaurs, and ichthyosaurs were gone. But in their place, fairly rapidly, within about 15 million years, evolved a new group, and that is the whales. We now have a pretty good sense of where the whales came from, and that was actually the group that includes cattle and sheep and so on, and hippos. And probably hippo is about the closest living sister group to the whale. This was discovered a few years ago by a friend of mine from the University of Michigan, Phil Gingrich. Went to Pakistan and found transitional things showing the ankle bones in the early whales match those of early herbivores. In the Paleogene time, we see plenty of insects on land. You could say it was a time of adaptive radiation of insects, for sure. And with these, a lot of other organisms coming in. The dinosaurs, of course, had gone, and this is sort of an odd little picture showing the skull of Triceratops, one of the last ones, with some small mammals chewing away at it. But in the early Paleocene, it took some time for recovery. We're at about 5 million years during this time. It was not very much bigger than a cat or a dog, but later on, much more appearing in the mammals within 10 million years. And what's happening is that there's this, of course, replacement of dinosaurs, both in the herbivore gills, and you see this is the percentage that was occupied by dinosaurs right up to the KT extinction, and then mammals take that place. And the same with predators, pretty much the same thing. So it's a very good case of replacement. Okay, let's talk a little bit about, I think you can kick that one for a few minutes. Talk about some of the freshwater basins that show us beautiful records of life during the early Paleogene. Certainly the most famous in North America is the Green River Basin. This lay between the Wasatch, Wind Rivers, and the Uinta Mountains, so it's sort of enclosed. Actually, the Larame's over here too. It's an enclosed basin receiving a lot of sediment, but at times when there was drying conditions, the deposit of a sort of a freshwater shaly limestone, the so-called Green River Shale. There were similar basins, by the way, in the Bighorn and in the Powder River, and these actually had coal being deposited in swamp-type areas. And there was also Uinta Lake in Utah and part of Colorado, which also features some pretty interesting fossil occurrences. So these are the so-called intermontane basins. This is what the Green River Shale, so-called, looks like. It's famous for two things. If you're a petroleum geologist, you think, well, the Green River, prior at least to the discovery of the importance of the Marcellus Shale, the Devonian, was considered to be North America's great reserve of oil shale. The problem is, in order to extract this oil shale, by quarrying it, it takes enormous amounts of energy and water, and this is a very dry, largely rather arid and desolate region where it's exposed, and so strip mining of the oil shale has never come about, probably fortunately. On the other hand, it's also famous for its fossils. The Green River Shale is famous. This is a big palmetto plant, and famous for its fossil fish that everyone has seen in the rock shows. And by the way, there's a rock show coming up pretty soon. Sam's not here to talk about it, but anyway, there is, anyone know what the date is? Doesn't matter. Next weekend, there you go. And you'll see these Green River fossil fish, which had mass die-offs in the lake, fell to the bottom. Bottom was anoxic and they were preserved. This is a freshwater stingray. This is a bird and a bat. And all those things fell into this. And it shows that by about 50 million years ago, in the Eocene, there was a pretty diverse life living around. There were even bird trackways of these odd, sort of long-legged ducks called Presbyornis, which are kind of the ancestor group for the ducks and the swans. There's a second place that you should know about that should be probably even more famous. It's almost the same age. It's mid-Eocene, and it's called Messel. The Messel is in Darmstadt, which is south of Frankfurt, Germany. And in this area, you had what was actually another oil shale pit. This was being mined for oil shale way, way back, and they were taking it, retorting it, or heating it up to drive the oil out. It was later on slated to become a garbage dump, but somewhere along the lines, people discovered there was extraordinary fossil assemblage within the Messel, and the UNESCO stepped in the last week before this turned into a dump and said, no, you save this as a World Heritage Site, because here you find such remarkable fossils that they're almost unprecedented. Insects and this beetle with the color still on. Here's a fossil of an anteater, which is very enigmatic. It should be in South America, but there it shows up in Messel. And this is a pair of mating turtles that, there were actually a whole bunch of these that died during what must have been a mating season or something, when there was also a blast of toxic water, and they all fell down. So there you go. The mammals still have fur and gut contents. There are horses known with very, very early horses, that don't look much like horses today, but that had even babies in the mother preserved. And all kinds of things are found in those oil shale deposits, frogs, of course, and snakes, and birds, and bats, an enormous assemblage. Now, the exact problem here, or issue of why you get this, is a little different from the Green River. That has these overturns and anoxia periods, but looks like the Messel Lake was perched right on a volcanic vent, and just like Lake Nyos that you might have heard about in Africa, where several years back there was a huge gas venting event, and a lot of toxic gas, well, a lot of carbon dioxide actually just burped up out from the top of the volcano. And the same may have happened here, which literally caused things to die in the air, birds and insects and stuff to just fall in the lake, and then and to be very, very, very quickly following these events. So it's an interesting case of what's called a Mar lake, and you don't have to know that, but a Mar is a lake perched on top of a volcano. So then we've learned a lot from the Messel. Let's continue and say a little bit about life on land, with an emphasis, of course, on mammals, and so some pictures there. You can see the big story here is through the Paleocene and going into the early Eocene, an explosive adaptive radiation of mammals. Within 10 to 15 million years, you have about 30 orders of mammals, everything from insectivores to bats in the sky, rodents and carnivores, herbivores, and even whales out to sea. So this was a really important time. And interestingly enough, the big predators initially were not mammals either. They were large, flightless birds like these gastroornithiforms, somewhat related to the modern chickens and things like that. But they were huge, and you can see a woman for scale. And these things ate horses. They actually known to have got contents of small horses in them. So you see the pictures over here. Exactly. Got just an early scene showing a predatory cat-like animal. These are Eocene dawn horses called the Geohippus or Hyracotherium, and these are sort of a taper relative. But you can see this is a lush forest setting as would have existed in the American West in these intermontane basins at times. Here's the big story right there. You can see just a tremendous diversification of mammalian orders. There's the giant flightless bird again. And again, that's the same picture, and we can click down for a moment. And you see here just a panoply of mammals showing up all very quickly following the demise of dinosaurs. They were filling those ditches, as I showed in the previous slide. And you see everything from the various types of grazing mammals to elephants, whales, bats. Primates are actually quite an ancient group. And on the island continents, odd things of marsupials and monotrees. Okay, yep. Click it for a moment. Here's a fossil bat from the Messel deposit in Germany, and you can see it was quite modern-like already in the Eocene. Had all the classic adaptations of a bat, spreading out its wing membrane on 4 fingers and so on. There were early carnivores called creodonts, which were partly arboreal like this, and were probably the forerunners. So it's sort of a sister group to the main predator groups that we know today. But by early Cenozoic, well, we have the development of the feliforms, the cat family, and the caniforms as well, the dogs, coming out of early common ancestor called the monastics. And then there's a very peculiar group of predators here shown, which were actually related to the grazing mammals and had this very elongate, had a huge, massive bone-crunching sort of ability. For many years, people thought these things, which are called the mesonychids, were the direct relatives of whales. It turns out that they're not, but they're a sort of a distant cousin group to whales. The whales are actually more related to the grazing mammals that have so-called even toes, which would include the relatives of cattle and so on. And here you can see a mesonychid. And you can also see some other odd Eocene ungulates. One was this very interesting thing called a Uintathere, or Dinocerat, which was not related to rhinos, but was sort of rhino-like, had these great big knobs on the head, and the Uintathere is, of course, named for the Uinta Mountains in Utah. This is an early horse, so lots of grazing mammals come along. Now I go back to that one for a moment. The dawn horse, Geohippus, not quite as large as shown here. It's actually about the size of a sort of a standard dog. And these things appear in the Eocene time. Originally called Geohippus, later it was discovered that an earlier name had already been applied, Hyracotherium, which means hyrax beast. This is sort of the ancestor of the odd-toed ungulates. The odd-toed ungulates include horses and rhinos, and on the back feet, these had 3 toes. Front, they had 4, oddly enough, but they reduced those down. And the whole story of horse evolution, which is shown in the classic mural here as a series of direct steps. Well, it was not as direct and straightforward as this, but the basic trends you can see: increase in size, reduction of toes from 4 on front down to 3 to just one single toe on the front of more progressive modern horses, elongate, more streamlined sort of legs, and the teeth are showing a huge trend from low-crowned teeth, which are good for browsing, soft vegetation, to these very high-crowned molars, which imply grazing upon silica-rich grasses, which evolved during this time, and the silica is so abrasive that in order to survive, these horses evolved these very, very high-crowned, tall teeth that grind down slowly, and they also got larger brains and so on. So the basic pathway all developed in North America. You see, North America was the homeland of horses. They then spread out to other places. At various times, different offshoot groups went across the Beringia, the Bering land bridge that existed at times, and into the Old World. Fortunately for us, the horses managed to do this one last time in the Pleistocene before going extinct everywhere else, and they managed to make it back into the Old World. Or I shouldn't say back, they made it into the Old World, and there they survived. But in North America, not at all. They had actually made it to South America, but then they went extinct there as well. It's only humans bringing horses back in that allows there to be wild horses in North America, but the ancestral wild horses are Asian. Okay, the first artiodactyl, too. This is the first of the even-toed or split-toed ungulates. This was discovered by a friend of mine, Ken Rose, a few years back, and Ken found this very cute little mammal, about cat size, but it already had the typical dew claws and cloven hoofs. It was sort of the forerunner of the artiodactyls. Now, the horses are charysodactyls, or odd-toed ungulates. These are even-toed. Then a scene from the reconstruction based upon the Badlands of South Dakota shows an Oligocene, okay, so later Paleogene scenario with a variety of mammals here, including pigs, early horses, and of course also relatives of the llama and camel group, relatives of the antelope group here, and predatory cats. Together with these giant things called brontotheres. Brontotheres were really in the rhino sort of group. They're related to rhinos and horses, but they were big, massive animals, which died out rather abruptly towards the end of the Eocene, or towards the middle of the Oligocene, when there was dramatic climate cooling, and we see tektites. Maybe there was some sort of impact. It was not a major extinction, but some of these big mammals did die out. But before that happened, the very largest land mammals ever evolved in Asia, and these are called Indricotherium by most people, and they had big, tall, giraffe-like legs. They're 17 foot high at the shoulder, but they were rhinos. They were in the rhinoceros group, and they achieved a pretty good size. Nothing like dinosaurs, but still, for land mammals, this was the peak. Let's see what else I got on here, just for... Okay, that's that famous South Dakota mural. Shows the Badlands with all its diversity. There's Indricotherium with a person for scale. So that was a pretty big rhino. Here are some of these big predatory mesonychids. And the relatives of elephants came out of Africa. They're called even Afrotheres, African animal mammals. And they evolved from something like this or this. This is called Moeritherium. Moeritherium was the first elephant in the early Eocene. Didn't have much of a trunk. It was about the size of a small hippo, pygmy hippo maybe. But by the end, by Oligocene time, there were these mega mammals that included big, strangely shovel-tusked elephants like this, or proboscideans, if you will, with a trunk-ish. But they also had this huge set of teeth here, and giant sloths and others. And lastly, maybe I mentioned the whales before. But the whales had their rise during the Eocene time, and they're coming again from something that was not a mesonychid, as people had said for decades, but rather was an actual artiodactyl, an even-toed ungulate. The proof is in the ankles, the so-called double pulley on the ankle, which is characteristic of all of that group, is found in Ambulocetus, which is an early, rather small whale, which was probably more like a seal or something like this, was sort of amphibious. It could go to sea, but also it spent some time on land. By the middle Eocene, middle late Eocene, we have something like Pachycetus, which was fully adapted. You can see from the name, a lot of these beautiful fossils came out of the famous Siwalik Mountains in Pakistan. And here you see an animal much larger and more fully adapted with a loss of hind limbs or a reduction and an elongated body. And finally, Basilosaurus, which occurs in the Oligocene of Egypt, has this really long, almost serpentine-like body, resembling somewhat a mosasaur of earlier time. But from these evolved the modern whale. So we have a really good sense of where they came from. There's just some pictures. Here's a really early, small relative of the whales. It does have the little cloven hooves, typical. Here's Ambulocetus going after a horse, and the Pachycetus. Hippos are about the most closely related modern group. And lastly, we should say primates during this time began their evolution. I think there was actually some hints of primates going back to Cretaceous time, but they began to radiate into at least these so-called prosimians, these things like lemurs and so on. And then during the next period, the Neogene, they really evolved into a wide array of animals, starting in the Old World, but eventually making their way to South America too. So about 55 to 58, you have Plesiadopus. It's about the size of a cat, actually, as a probable very early lemuroid type thing. By 35 million years, okay, this is putting us in the later part of the Paleogene, or about in the Oligocene. We see Egyptopithecus, named for Egypt, of course, which was an early, what's so-called catarrhine, or old world primate, that had that sort of elongate head and canines and so on. That means that it is probably close to the common ancestry of monkeys and apes. And that's 35 million. By 25 million years ago, in the late Oligocene, there was a key split that had happened in the primates between the catarrhines, which are the more protruded face monkeys and apes that have non-prehensile tails, and the South American group called the platyrrhine, or flat-nosed monkeys, which developed the prehensile tail. Just how that split took place is interesting, and people have argued, well, maybe the ancestors of the South American monkeys, clearly they came off this African stock. Maybe they were a small splinter group that happened to get across the Atlantic floating on logs or something. It's a very great example of what we call a sweepstakes route of dispersal, because only some small rodents and monkeys managed to make it across the Atlantic at this point, which was pretty wide by the time you're into the Oligocene. But there you have it. Okay. Now, on to the Neogene. And the Neogene is a very, very critical time, and so